Okay, at the end of last segment, we talked about two ways we want to use XML with a database. One is as a DDL, the other one is we want to talk about storing and retrieving XML. So let's go forward and talk about XML as a data definition language. So consider a well-formed XML document, simple one here for student course grades, where I declare a couple tuples, and those tuples have things like a student ID, their number, their student ID number or serial number, and what the grade is. All right. The implication is by seeing this structure over and over with these elements, right, that those common elements could map into a flat relational schema here, and the content model, the values go in their respective places easily. So I could take some XML documents and map them easily onto relations that way. And I say some XML documents because if you notice, this only has one layer of structure inside of each tuple, right? If I had multiple layers, it wouldn't quite be so easy because I'd lose that sense of hierarchy. Certainly going in the other direction, which I'll denote with a different color. All right, if I went in this direction, well, that is easy because in a standard relational schema, I only have flat relations. All right, so it'd be pretty easy for me to turn around and convert a flat structure like this into an XML document. So you can go back and forth between the two with relative ease, considering you have relatively flat data. But by itself, we have more cases than that. We have rich data that we want to do. We have further and deeper structures that we want to do. We may have XML documents that are garbage. I mean, how do we know that they're, just because they're well formed, they're giving us meaningful and useful information? How do we go ahead and query them and get data out of them? How do you basically know? What are the semantics of the document that you're getting in XML? Again, this one didn't have any declaration of any kind of use of a grammar, if you will, that tells us what the structure is. We're inferring it by looking at the tags. All right. So we need an idea of the structure, and in XML, there's basically two mechanisms for that. One's called a document type definition, or DTD, and the other is an XML schema. XML schemas are far more common now. DTDs are pretty much a legacy. You'll still find them around in some places. So we'll talk a bit more about XML schemas, but just give you an idea of what a DTD might look like. A DTD is an extended EBNF. I'm not going to write out extended Bacchus Noir format. It's a grammar. All right, that defines the XML structure. The XML document specifies an associated DTD plus a root element. So you would indicate in your XML file that you're using that doc type, all right, for a DTD. And so you'd have to have that. That's a new instruction here you have to put in. That's another type of processing instruction. Here's an example. DTD would tell you, for example, that you have a top level element, right? The top level element comes in the doc type. So then we would plug into this part of the grammar and say, oh, we have an element of type DBLP. And then underneath that element, I would have to have a master's thesis or an article, and I could have 0 or more of those is what the star means. And then I would go look, oh, there's a master's thesis. I don't have the article part on here, but if I had one, or if I used author here, I would refer to that. And I would basically build that structure iteratively, if you will, going down. Now, if you notice as well, this kind of grammar-like syntax, you should have seen something like this in your languages classes. Clean that up a little bit for you. In this format, there is some indication of attributes and what their types are, but in this case, we have a single ID. You can only have one ID type per element, and you have this character data, C data type, but there's also something called PC data or parse character data. Oh, there it is right there. So there are these, some indication of loose typing, if you will, some coarse grain types associated with it. Now, there's some important things to note about DTDs. DTDs capture that grammatical structure, but first of all, they aren't themselves XML, right? This is not, kind of fools you because you see these carets and you think, oh, it's an XML document itself. But it's not. There's no open and close tag. It's not well formed or anything like that. So it's a type of markup, if you will. It's a metadata file, but it's not in XML itself. So you have to have different tools for processing the DTD, which can be annoying. It doesn't capture database data types domains, right? We have character data and parse character data, but we don't have more restrictive types. We can't be very specific in our typing infrastructure. And when you can do type extension in something, it means that you can be very specific of the restrictions of types. You do this in programming. We'll see we can do that with XML schemas, but you can't do it in DTDs. The ID fields aren't good implementation of keys. So we saw an ID attribute there, I should say. And it says no element type may have more than one ID attribute. So the value of an ID attribute must be unique between all values of all ID attributes. So you have to be very careful across all possible values. So you really need a notion of a GUID, a globally unique identifier, in your DTD. Whereas and you kind of know in relational and functional dependencies, we talk about things like super keys and candidate keys and having more than one key for a piece of data, but you can't define that in a DTD. And then finally, you don't have any way of doing this object-oriented style of inheritance or functional dependencies, dependencies between different values of different elements or even attributes. And functional dependencies are something that you're going to talk more about next week in this class when you talk about normalization. So XML schemas aim to address the shortcomings of DTDs. When XML first became popular, everyone was using DTDs. XML schemas kind of fairly rapidly supplanted the use of DTDs for several reasons. First of all, XML schemas are XML themselves, so they can be parsed and managed using the same set of tools. Your metadata, your grammar, if you will, is itself an XML. It had some, I don't mention it here, but things, better handling of namespaces, for example. You can define keys using XPath. So you had this kind of navigational key that handled this hierarchical structure we're talking about in a tree. You had type subclassing. That's even more complex in a programming language. So for example, programming languages don't consider order of member variables. Here you could actually consider an ordering of your content model, including the sub-elements, sub-attributes, but the attributes on your elements. And you had subclassing by extension or by restricting. So you could extend or augment a type, and that was a subclass, and you could also do it by restriction or constrain the set of things that would happen in the subtree. And then you had some domains and built-in data types you could use, and you could even reference other XML schemas from within your XML schema. So a lot of more interesting things that you could do with an XML schema. What did an XML schema look like? A little bit more involved in that DTD example. First of all, we'd have a namespace declaration. This declared the prefix of this XML-NS or XML namespace. It will be indicated by a URL or URI really, but you'd see URLs at the top of your documents. These were namespace qualifiers. There may or may not be an actual document there that could do it. This is the default identifier for an XML schema, but you could define your own, right? These are things in the XML schema that you could use, but you could write your own schema that further restricted or extended types as much as you want, meaning you could extend and create your own grammar off of the base XML schema grammar. XML schema had things in it like declaration of elements. There's an element that's defined in that XML schema document, and its descriptor attributes, the name of the element and what type it was. So there's a type field, adding more type metadata. We could have a complex type, complex meaning had structure to it, multiple things inside it, multiple different attributes in here for a thesis type, and then a sequence, right? Now we can control the ordering of our subtrees underneath our thesis type, if you will, to appear in different ways and even indicate in a more human readable format what the different number of occurrences could be. XML schemas tend to be much more verbose than DTDs, so they were a little bit hard to read, and you could reference multiple schemas in the same document, so it could be kind of confusing to read these sometimes, but it was a lot simpler from a programmatic perspective to do what's called validation against it. Validation is ensuring that your document conforms to the XML schema that you're implying that you use. And now you could programmatically validate things and use the same XML parsing tools again that you're using to deal with the instance data. Designing XML schema or DTD, it's not, that approach isn't as formalized as relational data design. I mean, you could still do things like your ER diagram, right? You learned ER diagrams, you learned ER diagrams to the relational data model, right? As a algorithm transformation. Well, you could do this to XML as well. You can come up with that. Now again, if you want to use some of the um, uh, more flexible structures in XML, you might consider your EER diagrams and do that to XML instead, because the EER tries to give some facility for dealing with these more complex data types and the extensions and the hierarchy that I'm talking about. And again, that's EER, that's what I mean by these extensions for aggregation. No, we often already have data in our relations and we need to design the XML schema to import them. What I mean by that is, that direction I talked about of marshaling data in and out of the database before when I was doing that tuple example with the student ID, a lot of times we start with data that's already in a relational database and we want to export it or bring it out as a result of a query in an XML format. So very often the schemas that we would define were around the data interchange use case that I talked about before, meaning we had data in our database, we're doing a B2B scenario with somebody else, we had an API interface in front of it over here, an API interface over here, we define a database interchange format that typically would be XML, and when we did this kind of stuff and we pulled data out of here and wanted to send it that way, the XML format, the XML schema represented a contract of the API. It would tell this client over here what data it could expect in what format. So if I could write tools that conform to that schema, or I used an existing standard, a vertical standard like that SportsML, HRXML we were talking about before, NewsML was another one that was more MLs and you could shake a stick at, then I would know that if I could process that grammar and I understood those semantics, I know it will be in that document before I even received it. And there's great power to that, right? Typically when you go about your design of that XML schema, DTD, the key design thing, like a lot of things in design, is to find those central metaphors. What are the important types that you want to identify, those important object types? And then you design your schema around that, all right? The finer grain ones you leave to the leaf of the trees, to the deeper nested structures. You want to generally be careful about how deep in the structure you go. The deeper you go in an XML document, the more parsing that can be involved, the more expense there could be. So what I'm talking about is as we look at the shape of XML trees, and I'll have a little more on this later, but to give you a preview, I could have kind of looks like a Christmas tree, short and narrow tree, meaning the width of this is not that long, but the depth, there could be 5 levels deep in this tree. Or could I express that's an equivalent thing using less levels and more siblings, in which case I have a shorter and fatter tree. Well, that designed it, maybe this only has 3 levels, but more of the data is put inside the tree here, if you will. The reason why that's important is they're an expense. I mean, your ability to traverse differs. This is actually going to parse in a way faster usually, even though could be the same number of nodes, but you get to the leaf nodes faster. It can be easier to express XPath or navigational-like queries, meaning it's easier to pick a path down a tree because it's shorter. Whereas there's more metadata implied here in a structure that's deeper because there's more levels to the tree. And that's good as an organizing principle because there's a lot of decision points when I parse. There's a lot of categorization going on there. But it can get so fine-grained as to be harder to parse and a little bit too much details and minutiae, if you will, going through trying to understand where things are in a document. So in any event, understanding what your central objects are, meaning in whichever strategy you pick, you want to make sure your central objects are the things toward the top of the tree. Right? I'm going to talk about that more in a later segment. But have that be your organizing principle, the most important dominant domain objects, if you will, of anything that you're trying to design. And then the big decision that can get very confusing is, well, do I need to model something as an element or do I model as an attribute? Like even in our sample XML document or simple one up here, give me one with, I'm going to go all the way up to something like this. I could have created mdate as an element itself. I could have taken the key and made it an element itself and I made it an attribute. So sometimes it's kind of like dealing in ER modeling with weak entities and multi-valued attributes, and the conversion between those. Because you might think, okay, is that thing supposed to be an entity of itself, or should it be, say, a composite attribute, I should actually say. Um, and you know when you transform these things into the relational model from the ER model, you wind up flattening them anyway into its own relation. But from a design perspective, sometimes get a little dicey as to which way you go. And again, you got to kind of think about it, right? If an element has its own properties, or more than one of them, or maybe just an attribute as a single property like MDate does, or key, but you don't have to do it that way. You could always make it an element. Certainly an element is more general, but there's a few schools of thought on that. A lot of folks kind of make sure they don't create very many attributes. I personally think it's fine, just that attributes aren't quite as extensible because they're just a name value pair, whereas elements are a bit more extensible over time.